Welcome to example 5. This is another example of a ladder leaning against the wall, but this time we're asked for different quantities. So let's once again evaluate what we have. This time we're told that the ladder is 10 feet. And we're told that it's being pulled away from the wall at 2 feet per second. And we're trying to find how fast the angle between the top of the wall and the ladder is changing at when the angle is pi over 4. So we have to look at, because this talks about the length, this length changing, x changing, that is dx dt. So we know dx dt is 2 feet per second. We know that the length of the ladder is 10, which is our hypotenuse. Our hypotenuse is 10. And we're trying to find how fast the angle is changing. So we can call that d theta dt. And we want to know that when theta is pi over 4. So we have to think of what relationship, what formula do we know that can relate all of this together. We can't really use Pythagorean theorem because we're not looking for the length of a side or how fast the side is moving. We're looking for an angle. So what we know, since this is a right triangle, we can use one of the trig ratios. And since I have this angle and I know something about the opposite side and the hypotenuse, I choose to use sine theta. So I know that sine theta is going to equal to x because x is changing over 10. Now 10, the hypotenuse, the ladder does not change. That length is the same, just like in the last problem. This length remains the same, so it's a constant. But x is changing. X is moving. As the ladder moves to the right, this distance between the ladder and the wall changes. So that's a variable. So I leave it as x. Since this unit is called the applications of derivatives, let's take the derivative of both sides. And taking the derivative of sine theta, I get cosine theta. Using implicit, I have to get d theta dt because I'm taking the derivative with respect to t. I remember that this is a constant, so I can pull out the 1/10, and I take the derivative of x with respect to t, which is dx dt. Okay, so I know dx dt. I was given that. That's 2 feet. I know I'm trying to find d theta dt. What I need to know is cosine of theta. Well, at the point that I'm looking for, theta is pi over 4. So plugging that in, yes, I said plug, Mr. Zamora. That's cosine over pi over 4. D theta dt is equal to 1/10, and dx dt is 2. What is the cosine of pi over 4? That's radical 2 over 2. So radical 2 over 2, d theta dt, is equal to 2 times 1/10 times 2, which would be 1/5. So d theta dt is equal to 2 over 5 radical 2. And this would be in radian per second, because this is theta. So that would be in radian per second. And that's how we do that problem. That was pretty simple when we considered the fact that all we had to use was a trig ratio. So we are about to watch our last video, example 6. So please load example 6.